Okay, so let's look at our do now for today. We have says the length of a hypotenuse of a 45 45 90 triangle. So first thing I'm going to draw is a 45 45 90 triangle. That'll do. Okay. And in this 45 45 90 triangle, we know the length of the hypotenuse is 18 square roots of 2. It wants to know what is the perimeter of the triangle. Well, this is a 45 45 90 triangle, so the sides get S, S, and the hypotenuse is S squared to 2. We circle the given and we set up an equation. We have S squared to 2 equals 18 squared to 2. Both sides have the square root of 2, so that cancels out, and you're left with S equals 18, which means both of the legs of this triangle are 18. Perimeter wants you to add up all the sides. 18 plus 18 plus 18 square roots of 2 is 36 plus 18 square roots of 2. Come over here and look at the next picture. We still have a 45, 45, 90 triangle. So we're going to label the two legs S and S, and the hypotenuse will be S squared roots of 2. Circle the given, set up my equation. Well, it just so happens we were given S. S is 11 square roots of 2. So since Y is equal to S, Y is going to be 11 square roots of 2. To find out X, X is S square roots of 2. So that's S times the square root of 2. Well, S is 11 square roots of 2. So this turns into 11 times 2, which is 22. So yesterday we talked about basically trigonometry and all the different ratios that come up with trig. Today I want to talk about why trig is useful. So whenever we're doing right triangles, I always want you to try to use your other strategies first. So can you use the 30, 60, 90? Can you use 45, 45, 90? Can you do Pythagorean theorem? Or is this geometric mean? If the answer to all of those questions are no, then we're going to use trigonometry. Trigonometry helps us solve for missing sides and missing angles. So on this triangle, our reference angle is 49 degrees. So across from the reference angle is side X, that's going to be my opposite side. Across from my 90-degree angle, that's my hypotenuse. And then whatever side is left, which is across from my last angle, is called my adjacent side. It's touching my reference angle. So we're going to circle the opposite side because that's what we want to find. We're going to circle the adjacent side because that was given to us. So we're looking at SOHCAHTOA. We circled the opposite and the adjacent, so that's TOA. The way we set it up, our equation yesterday for TOA was tangent, in parentheses goes the degree measure, which is 49 degrees, equal sign, and the opposite side is going to be the ratio opposite over adjacent. So it's going to be X over 30. To solve this equation, we need to get rid of divided by 30. We need to get rid of the fractions. So we multiply by the fractions denominator, and the 30s cancel. On the other side, we have to multiply by 30. So when we do this, what we have is 30 times the tangent of 49 degrees equals X. This is called exact form. To figure out what X actually is approximately, we need to pull up our calculators and we need to go to mode. You need to make sure your mode is set on degrees. And then we just come back and we type in 30 times the tangent of 49, close parentheses. Let's round to the third decimal place, the thousandths place. So we're going to get approximately 34.51. So let's label the next example. Our reference angle is 15 degrees, so we have our opposite side, our adjacent side, and then across from the 90 degrees is our hypotenuse. I'm going to circle the hypotenuse because that's what we want to find, and I'm going to circle the adjacent side because that's the side that was given to me. So SOHCAHTOA, we circled adjacent and hypotenuse, so that's now our cosine. So we're going to write down COS, that means cosine. In the parentheses is our degrees, so 15 degrees equals, and then it's A divided by H. So that's going to be 7 divided by X. We solve this one exactly the same. We need to get rid of our fraction. To get rid of divided by X, we multiply both sides by X. On the right side, the X's cancel. So we have X times the cosine of 15 degrees equals 7. We still need to solve for X. So to solve for X, we need X equals. So we have to get rid of the cosine of 15 degrees to isolate the X. Well, this is X times the cosine. So the inverse operation of multiplying is dividing. So we're going to divide both sides by the cosine of 15 degrees. So at the end, we have X equals 7 over the cosine of 15 degrees. So that was the exact answer. If we want to figure out what the approximate answer is, I'm going to use this alpha y equals enter button to get my fraction. In the numerator was 7, and in the denominator was the cosine of 15 degrees. When I press enter, I approximately get 7.24. We'll round that 6 up to a 7. So 7.247 approximately. So the next example, we're not given the angle measure anymore. We're solving for theta. So find the value of theta. And that's just talking about what's the angle measure. So we're going to use this angle as our reference angle. We still have our opposite, our hypotenuse, and our adjacent side. This time we were given two sides, the opposite side and the adjacent. So in our SOHCAHTOA, opposite adjacent is going to be tangent again. So we're going to write down tangent. In parentheses goes our degrees. Well, we don't know what our degrees are, so we're just going to put theta here as our variable equals the opposite side of our adjacent. That's just going to be 9 over 13. Well, yesterday we talked about if we're solving for an angle measure, we have to do the inverse operation of tangent, which is called inverse tangent. And then we just type in 9 divided by 13. So when we type this in a calculator, we're going to get an approximate answer. So we'll type in inverse tangent, so second tangent, put 9 divided by 13 in parentheses. And we're going to get, let's round to the nearest tenth this time. We're going to get 34.6. Oh, we should round that 6 up since the 9's next to it. So this is going to be 34.7 degrees approximately.